Hi there, welcome back to this channel. In this video, we're going to be attending to some questions that are possible to be asked from the topic of viscosity in physics. Alright, the topic is viscosity, and I'm going to link a video in the description where the topic has been discussed. But at least let's go over some questions that is likely to be asked, and I believe that at the end of this video you'll be able to attempt more questions by yourself and understand the topic of viscosity even more. All right, let's go. Which of these best describes viscosity? That is the definition of viscosity, right? So viscosity we simply define it as fluid friction, right? Or friction in fluid. The ability of a fluid to expand when heated. No, that is wrong. That is expansion, expansivity. Is that okay? The measure of the fluid's resistance to flow. That seems like the answer. The pressure exerted by the tendency of a liquid to rise in a narrow tube, that is capillarity. So the answer is this, the measure of the fluid's resistance to flow. The next one says, what is the SI unit of viscosity? Now the SI unit of viscosity is Newton seconds per meter squared. So what would that be? So we have Newton per meter squared, Pascal per meter, so that would be. So Pascal, remember, is the unit of pressure. So pressure is force as Newton per meter squared, so times seconds. So the answer is D, Pascal seconds. So that's a unit of viscosity. Which of the following liquids has the highest viscosity? Which one has the highest viscosity? The best way or the easiest way to think of it is the higher the thickness or the more the thickness of the fluid, the higher the viscosity. So which of these will be the thickest? Of course, it will be the honey. So it will have the highest viscosity also. The next one. What happens to the viscosity of a liquid when its temperature increases? So we define increase in temperature as what? As what? Increase in kinetic energy. Increase in kinetic energy, because we said that temperature is basically in the molecular or at the molecular level is basically the measure of the average kinetic energy of the molecules that make up that thing. So here, what happens to the viscosity of a liquid when its temperature increases? If temperature increases, there will be more discombobulation, there will be more kerfuffle, there will be more random movement. So because of that, or there will be increase in KE, that's what I'm saying. There will be increase in KE, and if there's an increase in KE, there is, free flow. So because there's free flow, that is a reduction in viscosity. So viscosity will decrease. Is that okay? Which force is responsible for this viscosity increase? Gravitational? No. Frictional force, friction. That is the one that is responsible for viscosity, because we said viscosity is fluid friction. Is that okay? So that's why if you pour water, for example, water runs, but if you pour, let's say you pour the honey, for example, you pour it even with your strength, with great strength. As you pour it, the molecules just start going like, oh, leave me alone, leave me alone, what did you do? Yes, you understand? They are very so sluggish. So, and that's because of the high viscosity, because high friction that occurs within the molecules of the liquid. And that's why if that kind of fluid were to be flowing, okay, for example, you have ever poured palm oil, the red oil, you have ever poured it through a funnel, you'll notice that most of the molecules will be attached to the body of the funnel. You will have to use your hand to scoop and scoop before you get everything. In fact, you can't get everything to enter into the funnel and into the whatever keg you are, loading. So because of viscosity, there is sluggishness in movement. For a small sphere dropped into a viscous fluid, terminal velocity now. Terminal velocity, the first time I saw this equation, which is 2r squared rho s minus rho f g over 9 this. Now, the first time I saw this equation was in an aquaculture engineering textbook, so it might not be available in your textbooks. But I think, but that is the answer for the terminal velocity. That is, you will understand it when you are studying laminar flow. Laminar flow. So that's the formula for the velocity of a sphere in a viscous fluid. I mean, water also has its own viscosity, only that it is lower than that of oil, honey, syrup. You understand? Right. A liquid with high viscosity will dash. A liquid with high viscosity will flow slowly or move slowly. That's the point. All right, let's go. Flow faster? No. Show high resistance to motion? Yes. Be compressible, be lighter than it. So it will show high viscosity than a high resistance to motion. And you see, I'm talking about lightness. A highly viscous liquid is more tenable, is more tenable to be heavier. Is that okay? Because viscosity is also dependent on the density of the substance, and density is highly dependent on the mass of the substance. And mass multiplies weight, isn't it? So, of course, the higher the viscosity, the heavier the stuff should be. So, that option is very wrong also. Which law describes the force experienced by a small sphere moving through a viscous liquid? Okay. Okay, yeah. So that will be Stokes law, because that formula, I mean, I said when you're studying laminar flow, you have to learn of the Stokes law. The Stokes law states that the viscous force of a fluid is directly proportional to the radius, viscosity, and velocity of the fluid. Now with 6 pi being constant. So the way we write it is F is equal to 6 pi, I think this first, then R, something like that. Now this sign represents viscosity. Is that okay? All right. The last one says, now there are supposed to be 10 questions here. So you check the first comment in the description, the first comment below this video. That first comment will contain the number 10th question. So you can comment on that comment to comment your answer on that comment. All right. So in a pipe, the next one says, in a pipe carrying a liquid, viscosity causes dash. I think A, the liquid to accelerate, no. Viscosity causes the liquid to flow at the same speed. Okay, well, no. Okay, let's see, different layers of liquid to move at different speeds in a pipe. Then the liquid to stop flowing. The liquid to flow at the same speed. Now, these ones are out. So let's use an elimination method. But how about the liquid to flow at the same speed? Okay, no. If it's flowing through a pipe, so like I said, that funnel, some of those fluids will still be hanging on the body of that funnel. So it's only the ones that are closer to the center of that pipe that will move fast. So it will make different layers of the liquid to move at different speed. So it will now create what is called velocity gradient. So create what is called what? A velocity gradient. So the answer is C. Now for the number 10, do that which is in the description below. God bless you as you subscribe to this channel and share the video with your friends.